Alps evoke idyllic portraits of unspoiled nature with peaks, glaciers, and lakes. However, in reality, almost every kilometer of its landscape has been cultivated, urbanized, or eroded by human activity. Even those bits of the landscape that at the first glance appear intact become a reflection of the effects of climate change and the current conceptual, political, and practical inability of our society to deal with them. Retreating glaciers are the most striking phenomenon of all. They are formations of geological time which are melting in a matter of years. In the strata of the glacier, literally frozen in time, is a repository of the alpine microclimate. An enormous amount of data is stored in particles and molecules of air trapped in the layers of ice. Decoding this data reveals a biocomputational alpine panorama composed of exponentially increasing carbon dioxide concentrations, unique diversity of contaminants, and intense metabolic activity. Synthetic Crystallisations Research Studio will establish a new kind of relationship with emerging synthetic landscape. We will approach the Alpine glacier as a synthetic ecosystem whose materiality is formed in collaboration with living organisms and digital codes. Projects will explore the potential of intelligent multi-agent organizations to read and decode the formations of glacier, using snow and ice as construction material in order to envision a new sustainable and productive realm. We will investigate parametric and generative methodologies of computational design to create dynamic transformation processes of a landscape. Proposed inhabitation system would be optimized with aerial monitoring, machine learning, material programming, and biofabrication protocols. The landscape itself would turn into the constantly changing synthetic land, where machinic, human, material, and microbial agents are forming a productive narrative and mutual co-living. Each team will work with both material and digital computation of synthetic crystallization process.
We'll be exploring link between physical and virtual materiality of glaciers through the lens of information and digital representation. Working with the material in the lab, we will investigate possible topological complexities, while later we will extend it with temporality and dynamism existing only in digital tools. Using point clouds as a common representation of topology, we will bridge physical landscape with datascapes formed from surrounding information.
We will explore the glacier surface with computer vision algorithms by extracting and analyzing features and patterns of the landscape. We will also use remote sensing tools and databases to look back into the glacier's history and study how its ice cover changed over the years. Besides that, with the help of the generative neural networks, we will simulate and generate different variations of the ice melting inspired structures, which will help us to develop the site-specific design solutions.
Final projects will present a new kind of synthetic material systems, aiming at creating a temporal dynamic architecture and proposing new ways of interaction with the landscape.